This is Earth, 1,000 years in the future. Humans are long gone. What happened here? And what remains from our time on this planet? Well, today we're answering, if all humans vanished, how long would it be until Earth erased every trace of us? It's day one after every single human on Earth has disappeared. The streets are empty, the cars have stopped, bikes lay abandoned, the music gone silent. Squirrels and dogs and cats run through the city squares, along with the odd police horse. A bold coyote makes its way downtown. On the surface, the cities still look normal enough, minus the traffic and the crowds. Times Square and Shibuya Crossing stand barren, but the lights are still on. Traffic lights beckoning pedestrians to walk. The majority of hydroelectric and nuclear power plants are still operating, though no one is at the wheel overseeing them. Within a week, most will trip a routine breaker that a human supervisor would normally reset, and then the sprawling plants will shut down. Generators kick on in hospitals, their diesel motors keeping the city looking like it normally does, but they'll burn through their backup fuel within 48 hours. Generators running on natural gas will keep running longer. Cities start to go dark. They're still warm because most heating systems are built to run autonomously, but within a few weeks, natural gas compressors and distribution stations stop working properly due to pressure drops or power outages. In the colder parts of the world, the heat starts to turn off. In the warmer parts of the world, the food is rotting. Post-humanity smells. Within a month of humans disappearing, our usual comforts of modern life, electricity, heat, and running water, have mostly stopped working. Humans have built incredible automated systems to give ourselves power, control over the temperature of our homes, and nice warm baths. But guess what? Humans actually still do the stuff, or did the stuff, to keep all those systems running. Cities are blacked out. Wherever it's winter, towns freeze solid. Pipes burst, flooding houses and residential buildings. Fires and explosions are common. Behind the locked doors, it's basically cockroaches. Pets, farm animals, and zoo animals either die from starvation or escape their pens and homes and flood into the wild. Outside, it's pure chaos. Things have gone post-apocalyptic in real short order. Like in Chernobyl, packs of feral dogs stalk the streets at night. There is an exception, though. For cities that built their power grids around renewables, well, these solar panels keep turning photons into electrons. Wind turbines and hydro keep churning. In Reykjavik, the geothermal is still working. But all complex power systems have fail-safes and breakers that need monitoring and supervision, and without human direction, the major grids shut down, one by one. Within a year, all urban centers are dark and cold and silent. You remember books, right? Well, now, whether you had a library card or not, you'd have access to all kinds of critical information, if you could figure out the Dewey Decimal System. Outside of your home or apartment, the rest of the human world would start to slowly decay. The weeds and the riotous power of nature push their way into the human domain. Remember the pandemic? Yeah, those nature is healing videos. Well, most were fake, but now nature is starting to heal aggressively and overtaking the old human world. How long until it erases everything we've built? Well, we'll get to that, but you've probably been wondering, how did we disappear anyway? Now, the way humanity ends will have a lot to say about what actually remains for nature to heal. I've spent a decade YouTubing all the ways the universe could kill us, and there's just so many ways. On one end of the how does humanity die spectrum, it's possible that something out there in space could kill us. For instance, we've been keeping a close eye on the massive temperamental white dwarf star in the binary T Pyxidus system, about 3,000 light years away from us. Scientists estimate that it will go supernova in about 10 million years, which could completely destroy our ozone layer. So, what if we've missed a bigger, closer star that goes supernova without warning? It would hit us with a gamma ray burst so strong that it not only destroys all life on Earth, but also shreds our atmosphere and takes the entire crust off the planet. If we get hit by particles traveling 99% the speed of light, Earth gets sanitized. Or what if we don't spot an incoming asteroid, an interstellar runaway like 3I Atlas rocketing into our system at high velocity? That guy was doing nearly 7 kilometers per second, and if it hit, it was gonna do way more damage than the Chicxulub asteroid. And Chicxulub, which nailed Earth 65 million years ago, wiped out the dinosaurs. It incinerated forests, blasted trillions of tons of gas and lava into the atmosphere, and created a nuclear winter. That kind of impact would erase a lot of human achievement in short order, so it's possible an asteroid could disappear us, along with most of our infrastructure. Another option, what if we obliterate our own existence by starting a nuclear war? Yeah, the threat of mutually assured destruction hovered over us during the second half of the 20th century, and humanity still has over 12,000 nukes, which could kill millions in the initial exchange, and then billions with the radiation and the nuclear winter that would follow. But it wouldn't leave the planet looking like this. None of those scenarios would. They would just cause mass destruction. So, what would vanish us? Well, the most likely culprit is a superbug, a bioengineered virus or bacteria released en masse by nefarious actors. Bad guys with bad pathogens. This idea has been around since we really started fretting about the end of the world, post-atomic bomb. It was popularized during the height of Cold War Armageddon fears, emerging in sci-fi thrillers like Alistair MacLean's The Satan Bug. It was Star Trek stuff at the time, medical make-believe, but these days, researchers worry that a real Satan bug could be designed by rogue scientists and AI. Microbiologists bumped up against this recently. AI solved a complex superbug antibiotic problem, one that had taken researchers years to figure out, in just a couple of days. And it was just 2 years ago that scientists warned against research into creating mirror-life bacteria. While hailed as a good way to develop targeted, long-lasting drugs, the bacteria could also potentially kill any life on Earth that was exposed to it. Or we could be wiped out by a robotic superbug, tiny, self-replicating Terminator nanobots that disassemble human biology in minutes, leaving behind nothing but molecular dust and goo. Ugh. Either way, a biological superbug or a robotic superbug would have the same result. Every city still standing, every building as we left it. A pristine, museum-quality replica of the human world, with no humans in it, and no one to see it. All of us just gone. So, if humanity vanished, leaving everything we've built standing strong, how long would it be until everything we've ever created just fades to black? The decade after we disappear will be wild. Without maintenance, the world would burn, literally. Without any firefighters, heavily managed forests would be unprotected for the first time in decades. Mega forest fires would rip across the planet, consuming forests and cities in blazes we can't even fathom. Without irrigation, farmers' fields would turn to dust. Massive storms turning former wheat belts into dust bowls and desert. Dams would overtop and burst, flooding valleys that humans have lived in and farmed for centuries. And out of the ash and the dust and the flood, the world of plants and fungus would invade the places where humans once reigned. The first losses would be invisible. All those little waterproofing seals and window gaskets would fray and start to let water and snow into houses. Now, new homes are generally built to last 50 to 100 years, but roofs, as any homeowner can tell you, need to be repaired regularly. Without maintenance, the roofs of residential homes would start to fall in a decade or two. And once that happens, well, then the water gets in and the house begins to rot. Wet drywall equals mold and mushrooms and moss, and then insects burrowing into our most treasured possessions. Within 20 to 30 years, waterlogged houses would start to cave in on themselves. In big downtown condos, whatever's sealing those windows would start to fail around the same time, leading to the constant sound of full-sized glass windows falling from residential towers and shattering on the street below. With wide open windows, then moisture and plants move in. Everything warps and the structure destabilizes. Steel corrodes, rebar expands and fractures the concrete walls. Within 50 years, cheap condos and office towers start to slump over and fall. Soon after that, bridges and overpasses fail. Concrete cracks, particularly in colder climates where the freezing and thawing cycles quickly break it apart at the seams. Steel bridges rust, and without humans to keep up with painting and replacing struts and suspension ropes, suspension bridges collapse in spectacular fashion. Their swaying cables would snap, sending them tumbling into the sea. Now, on the upside, with us pesky humans out of the way, well, Earth's endangered species and fragile biodiversity would see a resurgence. We've seen nature rebound in places where humans have disappeared, like Korea's demilitarized zone, the DMV, thin strip of land where no humans have been allowed since the 1950s. It's now an ecological utopia, bordered by landmines. Within 100 years, most of our modern infrastructure collapses. What remains standing after a century are the buildings that were, frankly, built to last. Often built in the old ways with stone and masonry, government buildings, cathedrals, places of worship, monuments. There's a surprising number of freestanding stone buildings that have survived 1,000 years or more. Of course, they had human hands perpetually repairing them. Some are even older, like the Pantheon in Rome, which has been standing for over 1,900 years. It's an outlier, engineered with a special type of self-healing Roman concrete. But without any human oversight, these marvels of engineering would weather and sag and eventually fall apart. After 1,000 years, every major cathedral and monument would finally topple over. The Statue of Liberty would lie broken. Even the Pantheon's pillars would crumble, its iconic dome cracking and shattering in the dust. City skylines would be gone. The old towers of commerce, the glass and steel monoliths, would have long since rusted and crumpled, every city becoming a pile of rubble. The only buildings that would remain, in large part, are the buildings that previously stood for millennia. Stone temples and funeral mounds like the pyramids, cleanly designed, meant to last for eons. But the land would begin to bury them, the forests growing over them, the sand sweeping over the Sphinx once again. And while you might think, what about plastic? Plastic will last forever. Well, it usually takes 20 to 500 years to degrade into smaller pieces. After 10,000 years, nature would grow over everything. An alien visitor flying overhead would never be able to tell that there'd been a civilization below. But the buildings would still be in some recognizable shape buried beneath the ground. If an alien species had LiDAR technology, well, they could uncover great old structures in the same way that we do. It wasn't that long ago, back in the 1990s, that we realized the insane age of some of the buildings we've left behind in the past, like the ruins of Göbekli Tepe in southern Turkey. The archaeologist who rediscovered the ruins described it as a mound with no traces of prehistoric people visible, no walls. But beneath the soil was the oldest building in the world, built over 11,000 years ago. Similarly, we've found single buildings like the Knap of Howard, still preserved beneath the Scottish peat, a tiny farmhouse over 5,000 years old. So even after 5 to 10,000 years, our work would still exist, but it would be buried. Like the temples of Tikal, the great Mayan temples abandoned to the jungle over 1,000 years ago. When they were rediscovered, the buildings had been completely overrun by the jungle, just the limestone tips of the Mayan pyramids poking out from the hills in the thick forest. But beneath the ground, the buildings and burial sites were still remarkably intact after 1,000 years, and the steps still climbable. And it's not that uncommon. The famous terracotta warriors in China had been hidden in the mausoleum of the first Qin emperor, Emperor Qin Shi Huang, for over 2,000 years when they were found, with barely a scratch on them. It's somewhat fitting that the longest lasting marks that humans leave behind tend to be funeral monuments, gravestones. But time erases everything, eventually. After 100,000 years, even the terracotta warriors and the Mayan temples would crumble. Weathering, erosion, plants, and fungi would break concrete into sand, steel into iron oxide, into soil. Cities would barely be elevated mounds, the places we inhabited indistinguishable from nature. If you stood on a cliff overlooking Mexico City or Tokyo and gazed out at the world, it would look pristine. No remnants of these cities, just forest and grasslands, jungle. Nature would be completely recovered by now. The sounds of traffic replaced with the hum and the calls of wild animals. Without humans overrunning their habitat or hunting them, formerly endangered species would reclaim their natural footholds. Sumatran orangutans would proliferate across Southeast Asia. Amur leopards, whose population was driven down to less than 200, would hunt in great numbers again across the former Russia-China border. On the African plains, without fences or poachers, the great migrations would become truly great again. Families of endangered black rhinos and our cousins, the mountain gorillas, would thrive and grow. And the California condor would soar over the west coast in flocks once more. The one true legacy we'd leave behind? Our pets. Cats would survive just fine without us, thank you very much. And dogs? Well, they'd be our most impressive, lasting legacy. This is a dingo. They evolved around 5,000 years ago, not from wolves, but from escaped dogs. And these are dingoes 2.0, descendants of the surviving dogs of the Great Vanishing over 100,000 years ago. They hunt in packs, just like wolves and African painted dogs, but at heart, they're definitely still our old pals. Now, on the surface of Earth, humanity's best friend would become humanity's last remaining flag bearer. But deep underground, our presence might last longer. Don't forget, we discovered cave paintings dating back 50,000 years or more at sites stretching across the planet. We've found pictures of prehistoric life from Europe to Brazil to Indonesia, so there's a chance that our activity beneath the surface would also survive. Places like mine shafts, subway tunnels and their ancient graffiti, weird bunkers like the Churchill War Rooms, or the Svalbard Global Seed Vault and its 675 million seeds. Or the deep geological repositories drilled hundreds of meters underground, created to securely hold our nuclear waste. So yeah, the last remnants of humanity that someone finds might be a seed repository or a nuclear fuel dump. But eventually, even those will cave in. The Earth never stops moving. Over millions of years, tectonic plates will skate over Earth's molten core, subducting humanity's existence with it. Above ground, plants and animals would continue to evolve, and eventually, the next great intelligence would arise. They might be the descendants of our cousins, those endangered orangutans or mountain gorillas. Or they might be orcas, or octopuses, or crows. But eventually, some other species would become smart enough to dig around and invent their own paleontology and wonder, who were these crazy humans who left these fossils behind? Because Earth keeps evidence of everything. Though almost everything will be eventually destroyed by geological activity, our passing will remain for billions of years. We know this because we've found fossils of everything from T-Rex back to stromatolites, which lived over 3 billion years ago. And you gotta imagine we humans would leave some serious fossils. Which means that no matter what happens, Earth will never truly erase all trace of us. Not until the sun transforms into its red giant phase in about 5 billion years. And even then, it's possible that some remnant of humanity, a finger bone or a tooth, maybe yours, will remain buried deep beneath the surface until our planet's last days. Let's do this. Stretch your arms out as far as you can. From the tip of your right middle finger to the tip of your left, that is the entire 4.5 billion year history of Earth. Your right arm is a hellscape of molten lava. Your torso, a couple billion years of microscopic slime. Animals don't even show up until your left wrist. The dinosaurs arrive here. And all of human history fits here, on the very tip of your left middle fingernail. Yeah, Earth is old, and humans haven't been around that long. To put it in perspective, we're taking you back in time to the very beginning of Earth's existence, all the way to you right here. Around 4.5 billion years ago, the lights went on. That's our sun undergoing nuclear fusion. And in the midst of that gigantic cloud of dust and gas surrounding it was a big clump of rock and metal that gravity drew together into a planetesimal, which just means a planet that's not fully baked yet. Well, that's Earth. Soon, gravity pulled it into a sphere of molten lava. The heavy elements like iron and gold sank to the center and formed the Earth's inner core. That core is important because it created Earth's magnetic field, and the magnetic field shielded future life from all the sun's solar wind. But it didn't shield it from this. Just after the formation of the solar system, when Earth was still a glowing magma ball, a Mars-sized planet named Theia plowed into our future home. It hit it with enough force to knock the planet off its axis and blast a moon-sized ball of magma into orbit, which created, our moon. This was a violent time. Asteroids and comets smashed into our cooling planet on the regular. But they didn't just smash, They delivered water. Finally, Earth cooled off and developed a nice rocky crust, kind of like on that sourdough that you bake. We all got into bread during the pandemic. When the surface temperature dropped below the boiling point, it was cool enough on early Earth for water to condense and create the very first oceans. And that's when something wild happened. About 4 billion years ago, deep underwater, near hydrothermal vents, conditions for life began to form. You see, these underwater vents were rich with energy and minerals, including the 6 crucial elements for life, which are carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. In these unique settings, those 6 crucial elements could react with nearby ingredients like hydrogen cyanide and hydrogen sulfide to create the precursors to amino acids, lipids, and even RNA. Yeah, the beginning of life wasn't a cosmic spark. It was a series of chemical reactions. Chemical reactions that created an extremely complicated biomolecule. A biomolecule that did extremely complicated things, like make more of itself. And once it started, around 4 billion years ago, that chemistry was impossible to stop. 2.7 billion years ago, Earth's interior was hot. I mean, really hot. Much hotter than the ground beneath your feet today. All that intense internal heat was fueling a world of ancient volcanic islands. Down at the bottom of the ocean, that same heat was forcing mineral-rich water through massive cracks in the seafloor, literally injecting gold into the crust. This is how the planet forged the massive gold deposits we now find in Canada and Western Australia. The original gold from back when Earth was forming sank to the core, but later, asteroid special delivery restocked the surface, and those 2.7 billion year old volcanoes concentrated those space metals into the veins that we mine today. Okay, now let's fast forward for a minute all the way to about 30 million years ago. Earth wasn't just cracking anymore, it was exploding. In Nevada, supervolcanoes regularly exploded billions of tons of lava and ash across the landscape. One in particular, called the Atlantic caldera, blew its top and then collapsed in on itself. Well, that collapse shattered the ground and created the perfect network of pathways for gold-rich fluids to rise out of the magma and settle right near the surface. Yeah, this dramatic geological event brought gold to the surface. Okay, now let's rewind back in time to witness Earth's first mass extinction event that nearly wiped out everything. But it didn't start with an asteroid. It started with cyanobacteria. While volcanoes were rupturing Earth's surface, life on early Earth was getting a head start. Okay, back at your right bicep, we had Luca, the single-celled Great Times Infinity grandparent of every cactus, shark, and human on Earth. Its last universal common ancestor, LUCA. But by 2.7 billion years ago, Luca's descendants, cyanobacteria, were taking over. Earth's oceans were covered with these microbes, and they did something special, something that almost ended life on Earth at that time. They started photosynthesis. Cyanobacteria, for the first time in Earth's history, made oxygen from carbon dioxide. This changed the world. Up until this point, somewhere around my right shoulder, the world was full of methane. Cyanobacteria, powered by this new biological tech, photosynthesis, were hugely successful, and there were a lot of them. They pumped out so much oxygen that it replaced the methane in the early atmosphere. And then it triggered the very first mass extinction, the Great Oxidation Event.
Oxygen sounds great to us today, but 2.4 billion years ago, it was poisonous to all those OG anaerobic microbes. This atmospheric change from so much methane to so much oxygen wiped out most of early life on Earth. It was the very first mass extinction. The life that survived adapted to oxygen, which is really good at generating energy after breaking down nutrients. So life began to metabolize oxygen, and that was a great turn of events. Now, what's crazy about this whole timeline is we're halfway across the body, right near my heart, and we're still hundreds of millions of years from anything livelier than a kale smoothie. And life was still really tenuous for our little green cyanobacteria friends, because the change in atmosphere also changed something else. All that methane created a blanket of greenhouse gas that kept the planet nice and toasty. But then methane in the atmosphere decreased, triggering one of the first ice ages on Earth. For a couple 100 million years, Earth became a snowball. Yeah, Earth's climate has changed, but what didn't change is the constant threat from asteroids. Yeah, about 2 billion years ago, our planet was hit by a massive asteroid in what is now South Africa. That was the Vredefort impact. The asteroid that caused this impact was 20 kilometers wide. That's double the size of the asteroid that killed the dinosaurs. This asteroid hit with so much force, it folded the Earth's crust back on itself. This buried a massive gold field in South Africa, saving one of the world's largest gold deposits for us to find today. Yeah, dinosaurs were lucky not to exist 2 billion years ago. For photosynthetic creatures, this impact was brutal, but at the same time, it was kind of great for Earth. The impact of the Vredefort released dust and carbon dioxide into the air, and that may have helped Earth finally get out of its snowball phase. Around this time, Earth was one big supercontinent called Columbia, also known as Nuna. It was the first time almost all of Earth's continental crust was stitched together into one giant island. But this first supercontinent was about half the size of the final boss of all supercontinents, Pangaea. Columbia was a little smaller, stretching 12,900 kilometers from north to south. Now, even though there was oxygen in the air, you couldn't stand on Columbia's beaches without a spacesuit. That's because the protective ozone layer wouldn't form for another billion years. You'd be fried by UV radiation. But underwater, archaea microbes were hard at work. They were evolving, becoming more complex, and developing intricate relationships with other single-celled microbes. Eventually, one cell couldn't do without the other. Big cells swallowed small ones, forming cellular powerhouses known as mitochondria. These little things literally powered cells, taking in nutrients as fuel and cranking out the energy that kept and still keeps everything running. Eventually, all this microbial mingling led to the rise of organisms called eukaryotes. You see, a simple bacterium is like a studio apartment where things like DNA, proteins, and waste are all floating around in the same space. A eukaryote is like a luxury mansion with lots of rooms. In scientific terms, eukaryotes are organisms whose cells contain a nucleus and other specialized parts called organelles, all wrapped up in their own little membranes. You can remember them because it means you, as in you, a complicated multicellular creature. You are a eukaryote. But to start, they were really just way more complicated single-cell microbes. Somewhere in the next 500 million years, or most of my upper left arm, those complicated eukaryotic cells with all all kinds of internal structures became multicellular. Complex life was finding a way. Ever since the first supercontinent, Columbia, Earth has been figuring out how to best place its land. 1.5 billion years ago, Columbia broke apart, and around 1 billion years ago, Earth came up with another supercontinent, Rodinia. This was a massive and barren supercontinent. Back then, plants still hadn't evolved to turn the land green. Rodinia was so large and sat so squarely across the equator that it blocked warm ocean currents from reaching the poles. By the time we hit my left bicep, that's about 750 million years ago. Rodinia started breaking apart. And when it did, it rained a lot on Earth. It rained so much that it actually decreased the level of carbon dioxide in the atmosphere and caused the next snowball Earth era. But as the ice melted, life went into overdrive. Deep in the oceans, eukaryotes evolved into complex seaweeds and sponges. We aren't quite at the land plants or animals with bones stage yet, but somewhere right around my left wrist, life absolutely took off in an event called the Cambrian explosion. 530 million years ago, you were officially in the Paleozoic era, specifically the Cambrian period. Under the glittering Cambrian Sea, marine animals evolved hard. It was the time of mollusks, starfish, arthropods, chordates, you name it. Suddenly, life looked fast. After billions of years represented by sea slime, so much life happened between my wrist and my fingertip. A spike in calcium levels in the ocean allowed organisms to grow shells and skeletons. Well, that kicked off an evolutionary arms race. If one creature grew a shell, well, the next grew teeth. And to defend against teeth, the next creature grew armor. Meanwhile, the supercontinent Gondwana formed, which caused some problems for all those new branches of life. Around 444 million years ago, midway down my left forearm, Gondwana decided to take a slow-motion trip to the bottom of the world, right over the South Pole. This triggered a massive planet-wide deep freeze. The bad news is that massive freeze formed massive glaciers from water, because almost all life back then was still hanging out in the shallow seas. This was a bad turn of events. As the ice grew, the sea levels dropped. For marine life, no water meant no home, and no home meant the Ordovician extinction. This event wiped out 85% of all species on Earth. If you were a trilobite swimming around back then, well, your odds of survival were essentially zero. Once it warmed up, though, the kind of life we know and love began to develop. Fish, plants everywhere. And the kind of life we'd never want to meet, like armored, giant-jawed placoderms. 375 million years ago, just inches away from my wrist, something incredible happened. The creature Tiktaalik dragged itself out of the water, becoming the first creature to walk on land. To a fish, going on land wasn't an adventure to the unknown, it was a refuge from the giant armored predators in the water. And they walked around the first true forests with real trees. Not long after, geologically speaking, the supercontinent Pangaea formed, around 335 million years ago. This was the era where almost every piece of dry land on the planet mashed together into one giant, C-shaped megacontinent. Pangaea was a world of extremes, from a lush coastal paradise to a massive, scorching desert in the center. all surrounded by a single, terrifyingly vast ocean called Panthalassa. This wasn't just a barren rock anymore. It was home to giant insects, odd in-between creatures like the Gorgonopsids, and eventually the very first dinosaurs. But unfortunately for them, the Great Dying was just around the corner. The Great Dying was a near total reboot of the planet. Around 252 million years ago, right around the base of my hand, Earth went through the Permian-Triassic extinction, and it was deadly. A massive volcanic complex called the Siberian Traps erupted for 1 million years and pumped so much carbon dioxide into the air that the oceans turned acidic. It was so bad that 96% of all marine species and 70% of land animals vanished. This was the closest life on Earth came to being wiped out. Okay, we've reached the base of my fingers, and this was roughly the time the dinosaurs showed up. Around 175 million years ago, Pangaea started to crack. And it was a messy, million-year breakup that split the world into two massive sub-supercontinents. As the Atlantic Ocean began to unzip between them, the world's climate shifted, turning the dry interior of the old supercontinent into a lush tropical paradise. This world was the ultimate all-you-can-eat buffet for the stars of the show, the dinosaurs. With more plants to eat and plenty of room to roam, herbivores like the long-necked sauropods went through a massive growth spurt. We're talking creatures that grew to the size of 4-story buildings. They were so heavy that the ground literally shook with every step. These animal skyscrapers dominated the landscape of a planet that, after billions of years, was finally beginning to look like the home we recognize today. Okay, by the time we hit my first knuckle, about 145 million years ago, the planet was in the middle of its most iconic makeover. The continents had drifted into a messy, recognizable version of the map we have today. But there was one huge catch. Because the climate was so steaming hot and had zero polar ice caps, sea levels were at an all-time high, nearly 200 meters higher than they are right now. It was a planet of giant islands and lush tropical archipelagos, the golden age of the Cretaceous. And dinosaurs like the T-Rex and Triceratops absolutely ruled the planet. But the clock starts ticking on the most famous bad day in geological history. Just 66 million years ago, while the dinosaurs were busy dominating every corner of the globe, a 10-kilometer wide asteroid was lining up its sights with the Yucatan Peninsula. In a literal flash, 160 million years of reptilian rule ended in a boom. The aftermath of this cosmic impactor wiped out 75% of all species. Think full nuclear Armageddon followed by nuclear winter. No land animal larger than 25 kilograms survived. But we did, or rather our shrew-like mammal ancestors did. Thanks, little buddy. And with the dinos out of the picture, mammals took off in all directions, quickly filling all the ecological niches their former dino overlords had occupied. Within 30 million years, those crafty little mammals evolved into bats, herbivores, and carnivores. Okay, by the time we hit my last knuckle, modern mammals had appeared. Even seemingly complicated mammals like toothed whales and baleen whales had already evolved to dominate the sea. By the time we get to my fingernail, the earliest known humans set foot on Earth. And by set foot, I mean the smallish species Sahelanthropus literally got up off all fours and started occasionally walking around upright on two legs. You know, like my cat sometimes does when there's a fly. Within a couple million years, early hominids like Lucy, the Australopithecus, walked around upright full-time. 800,000 years ago, the first humans discovered how to control fire. And it was lit. They could cook and keep warm. 40,000 years ago, Homo sapiens became the last surviving humans. And about 5,500 years ago, right at the very tip of my fingernail, this was the time when human civilization began. Nearly 4.5 billion years after Earth formed, an organism evolved that was able to read and write and start asking big questions about how they got there. And we're still here, asking questions, trying to figure it all out. It's been a wild ride. There's a problem with Earth's core. It's right here under our feet, but we've never actually seen it. Today, we're going to fix that. We're going to find a solution to drill all the way to the center of Earth. And then we'll see you fall right through the planet. This is going to be fun. Or not. Okay, let's open Earth up. Before going all the way to the core, you need to drill through the crust. Now, humans have attempted to drill through Earth's crust before, but as we went deeper and deeper, we had to shut that down and seal it off. We didn't even get that deep. Yeah, this is the Kola Super Deep Borehole. It's deeper than the Mariana Trench. It's the deepest place on Earth. Scientists started drilling it in the 1970s, and over the course of 2 decades, they went through unexpectedly extreme temperatures, deep granite oozing like hot plastic, and snapping drill bits. And in 1989, the project was shut down. The Kola Super Deep Borehole is 12.3 kilometers deep. That's 7.6 miles. It's significant, but compared to the Earth's radius of 6,378 kilometers, it's barely scratching the surface. To get all the way to the core, you'd have to drill a lot deeper. Specifically, you'd need to drill 6,378 kilometers deep to reach the center of the planet, and then another 6,378 kilometers if you wanted to dig a hole through the entire Earth and get out the other side. But let's start with the crust. The crust is the very top layer, and it's not very deep. Under the continents, it stretches between 40 and 70 kilometers, and it's mostly composed of lighter rocks like granite. Now, under Earth's oceans, that crust is only about 5 kilometers thick, but it's denser basalt rock. Now, choosing the right place to drill would be the first and most important step in your digging journey. If you started drilling your hole anywhere near the equator, well, you couldn't fall through it. That's because Earth's rotation would become a problem. Yeah, this is what scientists call the Coriolis effect. Even though Earth makes one full rotation every 24 hours, not everyone on the planet is moving at the same speed. It all depends on how far you are from the poles. At the equator, the surface and you are rotating eastward at about 1,600 kilometers per hour. It's 1,000 miles per hour. You could drill a straight hole at the equator, but you couldn't fall through it. Because of the Coriolis effect, you'd be slammed into the eastern wall of the tunnel almost immediately. Now, to save yourself from slamming into a wall, the tunnel would need to be a complex, mathematically precise curve. That's too much math for me. Now, at the poles, which are Earth's axes, there's barely any sideways rotation. Here you could drill straight down. But which pole would you choose? The South Pole is on the continent of Antarctica, and the crust here is extremely thick, between 30 and 40 kilometers deep. The North Pole is right in the middle of the Arctic Ocean, and it sits directly over the Gackel Ridge. This oceanic crust is much denser than the continental crust, but it's thin. Here, tectonic plates are pulling apart so slowly that Earth's crust is less than 4 kilometers thick in some spots. So, by starting in the Arctic Ocean, you'd hit the Earth's mantle almost immediately. But you'd have to drill underwater, and that would make things difficult for you. This ambitious drilling project would take a long time. I mean, the Kola super borehole at 12 kilometers deep took scientists 24 years to drill. So, on average, they drilled about half a kilometer per year. Now, if you found a solution to the melting equipment problem and kept drilling to the core at the same pace, it would take you 24,984 years to get to the center. If you wanted to have this hole all done today, you'd have to have started this project during the last ice age, when mammoths were walking around. And you'd have to approach every one of Earth's layers in a different way. For starters, the crust. Columbia's mid-Cauca belt sits on a crust that's about 45 kilometers deep, so you'd have a lot of work to do. Now, for the first few kilometers, you'd use conventional rotary drilling with diamond bits. Yeah, I mentioned this was going to be costly. That's exactly why you'd be going through the gold-rich rock first. But as you went deeper, the rock would get so hot, it would be like drilling into hot, squishy plastic. German scientists once drilled a hole 9.1 kilometers deep, and they clocked the temperature 265 degrees Celsius. That's over 500 degrees Fahrenheit. Drilling in Colombia would get even hotter, and at the very bottom, the crust could be as hot as 1,000 degrees Celsius. Yeah, any mechanical drill would become useless. You'd have to switch to millimeter wave directed energy drilling. This is a kind of super-powered heat laser. A surface machine called a gyrotron would send waves down a metal tube through the crust. There, it would heat up the rock so much, it would practically vaporize. If you blasted this laser into the crust 24/7, well, it would take you 1 year to get to the bottom. The next stop is the mantle, specifically the upper mantle. The upper mantle stretches from 45 kilometers to 670 kilometers deep. It's mostly made up of rock called peridotite, but it's very, very hot, around 1,500 degrees Celsius. You'd need an extreme heat-resistant suit to go down there. And, of course, you'd keep using your laser to cut through this rock. But here's the problem. This intense temperature down here turns rock into thick peanut butter. You ever try poking a hole in peanut butter? It doesn't stay as a hole, does it? It closes. So your hole to the center of Earth would keep closing as you were beaming it. The only way around that would be to somehow crystallize the walls of your tunnel to the planet's center as you drilled. It would be a long and difficult process, and we don't even have the technology to do this right now. But if you somehow kept drilling at the same pace you drilled through the crust, it would take you 14 years and 4 months to get all the way down to the lower mantle. Yeah, you worked so hard and so long, and you still didn't even drill through the whole mantle. Now, the lower mantle is unimaginably extreme. At this point, you'd be drilling through deep earth, fighting through crushing pressure over 1.3 million times stronger than on Earth's surface, and soaring temperatures of 3,700 degrees. That's 6,600 degrees Fahrenheit. The heat radiating from the walls would be enough to incinerate any material. If you were planning to get this deep into Earth, you'd need advanced active cooling. And you guessed it, we don't have that kind of tech right now. The lower mantle is very thick. It stretches from 670 kilometers to 2,890 kilometers deep. If you could even keep up with the speed you've been drilling earlier, well, it would take you more than 50 years to get through this incredibly hot and thick layer. Finally, after 66 years of non-stop drilling into the planet, you'd get to the outer core. You're not at the core yet, but you'd be close. Here, everything would change. You'd no longer be in solid rock. The outer core is an unimaginably vast, turbulent ocean of soupy liquid iron and nickel. The temperatures here are so extreme, they're in the same range as the surface of the sun. Yeah, if you thought the mantle was hot, well, the outer core is between 4,500 and 6,000 degrees Celsius. I have no idea how you could survive here. This kind of temperature and all that pressure would incinerate and crush you within milliseconds. And if you did survive, well, drilling here would be impossible. You just can't drill through a liquid. You'd have to sink a physical, indestructible pipe through the molten metal to keep your tunnel open. And you'd be sinking 2,260 kilometers of piping into a swirling liquid iron ocean. But here's the good news. Instead of mechanically pushing it down, you could just let gravity do the work. If your pipe was made of an ultra-dense material that's heavier than the surrounding liquid iron, well, it would sink under its own weight. And it would sink fast. That's because the liquid iron in the outer core has a consistency similar to water, even though it's over 10 times denser. So it wouldn't create much resistance for the pipe. It would take you a little over 5 days to push the pipe down. Now, the outer core is what generates Earth's magnetic field. Yeah, all that molten iron moves around because of extreme heat and the planet's rotation. Because this liquid metal conducts electricity, all that swirling creates a geodynamo effect. It's like a massive natural generator. It generates the electric currents that power our magnetic field. And because of all that, the magnetic forces here would be 50 times stronger than you experience at the surface. Your navigation equipment and electronics would be useless at this point. You'd be drilling blinded by Earth's magnetism. But like I said, it would take you a few days to sink through the entire outer core. And finally, you'd reach your destination. Well, almost. Earth's inner core stretches from 5,150 kilometers to 6,370 kilometers. You wouldn't be at the center of Earth yet, but you'd be close. The pressure here would be 3.6 million times higher than the pressure at sea level. And the temperatures would be hotter than the surface of the sun, up to 6,000 degrees Celsius. That's over 10,000 degrees Fahrenheit. Now, you'd think it would be another layer of metallic soup, but no. The core is dense, all because the incredible pressure is keeping it solid. You'd re-engage your laser beam. Hopefully you took that thing with you through the outer core. Now, there would only be about 1,220 kilometers between you and the center of the planet. With your laser drill, it would take you just under 28 years to get there. But finally, you'd be standing at the very source of the force that keeps your feet on the ground, right at the center of the planet. But you'd feel absolutely nothing. Now, we think of gravity as a downward force, but down just means toward the center of mass. As you drill toward the core, more and more of Earth's mass would actually be above you. Once you were in the center of Earth, inside a solid sphere, the mass of the planet above your head would cancel itself out. The gravity from the bits of Earth to your left would be canceled out by the bits of Earth to your right, and the stuff above you would pull you up just enough to negate some of the pull from the core below. By the time you reach the exact center, you'd be in the middle of a global tug-of-war where every side is perfectly matched. You would just drift in the middle of it, just like an astronaut on the International Space Station. Every atom of the Earth would be pulling on you, but because they'd be pulling in every possible direction at once, the net force would be zero. Now, to get to the other side, you'd have to repeat the entire process in reverse. From the center, you'd have to drill through another 1,220 kilometers of solid inner core. Now, since you'd be working against gravity, even though it's weak at first, it would feel like a constant uphill climb. Then you'd blast through the 2,840 kilometers of mantle and the final thin layer of crust. If you kept your laser drill running at the same record-breaking speed, well, the entire return trip from center to the surface would take another 90 to 100 years. Okay, so your megatunnel is finally finished. It goes from Columbia straight through the core all the way to the other side of the planet. And now is the time to send you through it. You put on a heavily shielded spacesuit, pump all the air out of the shaft so that the air resistance doesn't burn you up, and then you jump. At first, it would feel like regular skydiving, only you'd keep accelerating because there would be no air to slow you down. Your speed would keep climbing. By the time you hit the mantle, you'd be moving at insane speeds. Exactly 21 minutes after the jump, you'd blow past the center of the Earth at 8 kilometers per second. That's about as fast as the International Space Station zips around Earth. You'd blast through the zero-gravity core at maximum speed, and now you're heading up the other side of the planet. Gravity would be pulling against you now, and it would slow you down. But your massive momentum would carry you all the way out through the outer core, the mantle, and the crust to the opposite side. Exactly 42 minutes after you jumped, you'd pop out the other end of the hole. Your speed would hit zero for a split second at the surface. You'd be right in the middle of the Indian Ocean, near Indonesia. Now, if you didn't grab onto the ledge at the exact second you reached the surface, gravity would pull you right back down. You'd fall back toward the core. You'd be falling back and forth inside of Earth forever. Yeah, you probably shouldn't have jumped here, but it's too late. You're stuck. Since the beginning of time, Earth has created life and then wiped most of it out in catastrophic, ultra-destructive moments. Early Earth was already a hostile place, but these savage events were the absolute worst periods in history to be alive. So naturally, I thought it'd be fun to send me there. You know, to cover it live. Or more likely, dead. Obviously, I can't travel back in time, but DigiPeter can. In this video, we'll show you just how you would die during the most dangerous times Earth has ever seen. Starting with the very first extinction event since multicellular life began, the End Ordovician extinction. The Ordovician period started almost 500 million years ago and lasted nearly 50 million years. This is a time of planet-wide oxygenation and incredible leaps in biodiversity, known as the Great Ordovician Biodiversification Event. It's so far back in time that the very first species of plants are only now starting to populate the land. In the early to middle parts of this period, it's hard for mammals like you or Digipeter to breathe. Oxygen makes up just 14% of the atmosphere, but near the late stretches of the Ordovician, say 450 million years ago, the oxygen is as high as modern day, or even higher, pushing 24%. Now, it might not look like much is happening on land. All you'd see here is algae and the first land plants, these little liverworts, which are kind of like moss. And there are no animals yet, which is fine, nothing to eat you yet. But under the surface of those ocean waves, Earth's biosphere is exploding. The first fish are out there swimming around. Jawless fish, armored fish, and even early sharks roam the sea. There's an incredible diversity of reef-filling animals like coral and one of my favorite fossil animals, trilobites. Trilobites in all shapes and sizes, in all ecological niches. They rule the underwater world and its warm, shallow oceans. They're kind of like crabs, horseshoe crabs, so it's a pretty yummy time to be around. That is, if you can go without butter, which won't be around for nearly 500 million years. And I'm not the only one who thinks trilobites are tasty. Fascinating creatures like the cephalopod Endocerus, a unicorn-like nautiloid predator with a long, straight shell who grows to lengths of up to 6 meters and feasts on trilobites. But this Earth is very different from the Earth you know. It's dominated by a supercontinent known as Gondwana. And when Gondwana drifted and settled near the South Pole roughly 444 million years ago, the planet began to change. It got cold. Suddenly, the Gondwana landmass was becoming the center of mass glaciation, turning water into thick land ice. Digipeter should have brought a parka. Sea levels drop rapidly, and the shallow seas drain without warning. Ice ages can cause seas to drop as much as 120 meters. That's 400 feet. That pulls the shoreline right back to the continental shelf. For life in the shallows, there's nowhere to go. Ocean temperatures, where all the complex life lives, drop by 5 degrees Celsius. Atmospheric carbon dioxide drops as well, but it's really the cold that starts eradicating Ordovician life. Yeah, it's way too chilly for these creatures and plants that evolved in warm, shallow oceans. Once their cozy habitat is torn from under them, it's goodbye. So many beautiful, delicious trilobites are gone. Over 100 marine invertebrate families disappear, and over 85% of all marine species die off. And at the end of the Ordovician, you're cold and hungry. There's nothing to eat except the odd scraping of algae. Eventually, you run out of food, and just like some lost, wandering Antarctic explorer, you freeze to death near the South Pole. Man, I'm getting chills just looking at him. Okay, let's take a look at the next extinction era, the late Devonian. The late Devonian period started just over 380 million years ago. Earth is greener now. Plants have fully settled on land, and early forests of ferns and Archaeopteris trees stretch along rivers and seas. For Digipeter, it starts out as a pretty good time. There are some odd but pleasant forests to wander through, no dinosaurs to hunt him yet. And since he brought his fishing pole, he's in luck. Because underwater, this is the age of fishes. Swimming through massive reefs in shallow seas are the first jawed fish, like the fearsome armored placoderms with their massive bony armor and heavy jaws. These terrifying predators grew to enormous sizes, up to 10 meters long, that's 30 feet. It's also a time when the Sarcopterygians, the lobed-finned fish, evolved. Now, they may not look so special, but believe it or not, this fellow is Digipeter's ancestor. And yours. It's an interesting time to be alive. Within a few million years, another lobe-finned fish, a relative of the one Digipeter just caught, called Tiktaalik, evolves the ability to crawl onto land. That's the first creature to set foot, or fin, out of the sea. They're not dangerous to a speedy, evolved biped like Digipeter, but they are fascinating to see firsthand. Meanwhile, Digipeter has trees, which means he has wood, so he can build himself a little log cabin or a shelter. He can watch his great ancestors flourish. His veggie diet is lacking and he's reliant on rainwater, but oxygen is near modern levels. Digipeter is thriving. But nearly as soon as it started, the late Devonian went through a series of extinction events that lasted 20 million years. One of the biggest killers of this era wasn't an asteroid or an interstellar object. It's all these darn plants. Yeah, trees. You see, trees evolve seeds and roots for the first time, and those roots grow right into the bedrock, releasing incredible amounts of nutrients. In our era, tree roots are everywhere, but at this time, they trigger mass algal blooms, depleting oxygen from coastal waters. And those algal blooms eventually die off and start to rot, forming gigantic mats of dead organic material. The seas turn anoxic, and marine life suffocates. During this period, there's also evidence of volcanic activity and possible climate swings. But the real killer in the late Devonian is the drop in marine oxygen. Toward the end of the Devonian period, you witness mass die-offs in reefs and fish, entire families that will never recover. 75% of species are lost. The monstrous armored fish disappear, as do most of the trilobites, never to be seen or cooked again. After thriving for millions of years, Digipeter struggles. By 360 million years ago, the oceans stank of rotten algae. The fish have disappeared, there's not much to eat, and you and Digipeter drop weight fast. You're starving, and one day you get desperate. You eat some washed up fish and a rotting trilobite. In one horrific gastric episode, you get a historically bad case of food poisoning, and you go extinct in the late Devonian. But that's nothing compared to the next mass extinction event, known as the Great Dying. Okay, fast forward 100 million years or so, toward the end of the Permian period. This is the supercontinent Pangaea, a single landmass spanning most of the planet, surrounded by a global ocean. Ferns and plants burst forth, creating habitat for amphibians, reptiles, and even mammal-like reptiles like these therapsids. All kinds of weird creatures walk the land. Animals like gorgonopsids have evolved to serious predators. For Digipeter, it's getting a little dodgy out there. There are big boys wandering around these forests, like the sail-finned Dimetrodon, which looks like a dinosaur but is way older, by 40 million years. And the gorgonopsids, they're like saber-toothed tigers that haven't quite finished baking yet. So many of these creatures don't really remind us of anything that exists on Earth today, or even in popular memory, like the dinosaurs. That's because, spoiler alert, the Great Dying is just around the corner. 260 million years ago, a series of volcanoes in China erupted, and 252 million years ago, Siberia basically exploded. turning into one massive volcano for hundreds of thousands of years. In what's now called the Siberian Traps, a nearly inconceivable level of volcanic activity happens, spewing out tons of lava, submerging everything in molten rock. DigiPeter is on the run, spending most of his days dodging lava flows and trying to get anywhere that isn't covered in lava. Now, lava is clearly bad for life near Siberia, but the bigger, planet-wide problem is global warming. Those volcanoes pump nearly unlimited carbon dioxide and sulfur into the atmosphere. Some estimates put the carbon dioxide levels at 20 times today's levels. Worldwide temperatures go through the roof. Oceans get hot, dissolve less oxygen, and become anoxic. Marine systems suffocate, mass die-offs, and then it gets worse. For you and DigiPeter, life sucks. The whole world smells like ash and sulfur. It's rotten eggs. Sulfur becomes a killer. There's so much of it in the air from the volcanoes and sulfur-producing bacteria that it causes intense, widespread acid rain. It acidifies the overstressed oceans, strips the leaves off the trees. Forests start to wither. 96% of all marine species and 70% of all land species die. Entire lineages disappear. This is as close as it gets to the end of life on Earth. And for you, well, there's nothing to eat, and the water is basically high-test vinegar. Dehydrated, you begin to starve. The only company? Other desperate creatures hunting you through the desiccated remains of forests. They drive you to exhaustion before closing in and tearing you to shreds, before they too perish from the worst mass extinction event in history. But it's certainly not the last. It takes millions of years to recover from the Permian extinction, but by the end of the Triassic period, nearly 200 million years ago, life had recovered. Dinosaurs began to appear, though this is really the time of phytosaurs, animals similar to crocodiles. DigiPeter has recovered from the trauma of being eaten by miniature saber-toothed prehistoric animals and is back to tromping around Pangaea, trying not to get eaten by archosaurs or those croc-like phytosaurs. But the supercontinent of Pangaea is starting to break apart into separate land masses. DigiPeter is in for a geologist's dream, watching the Atlantic Ocean begin to form as North America splits from Africa. Of course, this kind of tectonic action is accompanied by, you guessed it, volcanic activity. And volcanic activity pumps carbon dioxide into the atmosphere, which leads to changes in climate and the ocean's chemistry. Habitats shift and huge numbers of land animals vanish. But it seems that this extinction event is more selective. While entire families of marine reptiles and phytosaurs go extinct, fish, true crocs, mammals, turtles, and dinosaurs seem to survive without much impact. As for DigiPeter, well, he seems to be doing remarkably fine for living in the midst of a mass extinction event. While the Triassic extinction is similar to the Great Dying, it doesn't hit everyone the same. He's got food, fish, turtle eggs. He's occasionally suffering from some heat stress and dehydration, but he's not freezing to death or starving. So, how would you die during this period? Old age? Maybe. As far as mass extinctions go, this one is pretty peaceful. You've got food, shelter, water. That said, to the surviving crocs and early dinosaurs, you're basically a slow-moving steak on legs. Hey, alligator pie. And unfortunately for DigiPeter, I'm feeling a little curious as to which one of these predators would make him alligator pie. So I reached out to our friends at Versus to find out. Hey, welcome.
Hi, thanks for having me, Peter.
Sure, yeah.
Hi, I'm the host of Versus, and our guest would probably have to be the Postosuchus. I actually brought a little representation here.
Oh, he's just a wee little guy.
Yeah, his foot's kind of falling off,
no.
but we printed off this prehistoric monster, and it was kind of like a hybrid between a crocodile and a T-Rex. As it walked on its back two legs, and it would use their forearms kind of like grappling hooks to grab any prey that got near.
So like a T-Rex, but it's smaller like a crocodile.
Exactly, that hybrid. But
yeah.
I think the craziest part was that it had a head over 3 feet long. That's the size of a toddler, and it had teeth like serrated daggers. So there's a reason why this guy was the apex predator.
Yeah, so he's gonna kill Digipeter.
Yeah.
Well, that sounds like Digipeter's time in the late Triassic is not gonna be pretty.
No.
So is he better off in the Cretaceous?
Unfortunately not. See, predators like the Deinosuchus, which was basically a prehistoric alligator, would also be on the hunt for him.
And, same size?
Well, actually way bigger, massive. So to show you just how big he was, here, you can hold on to this, and I'll show you just how big the Deinosuchus was.
So this guy's, whoa!
This was the Deinosuchus. This guy was around 15 to 16 feet long. This guy over here was about 40 feet long, which is about the size of a school bus. Just massive.
Except it's a crocodile.
Except it's a crocodile, yeah. So Deinosuchus would most likely ambush Digipeter by the water and swallow him whole.
So which one is Digipeter worse off against?
Yeah, so you probably think the Deinosuchus, but we actually put together a full episode breaking down which one of these prehistoric reptiles would win in a fight. And crazy enough, it's one of our best and craziest fights we've ever done on the show.
These two are gonna fight each other.
These two are gonna fight each other.
All right, well that sounds awesome. Go check that out now on the Versus channel. And what about Digipeter? Sorry, Digipeter. Now let's move on to the most famous of all the mass extinction events. The one, the only, Cretaceous Paleogene extinction. The end Triassic extinction opened up golden ecological opportunities for the fledgling dinos, and by 66 million years ago, the age of dinosaurs was in full swing. Earth is warmer than today. There's hardly any ice at the poles, sea levels are high, and rainforests grow across the planet. And they're populated almost entirely by dinosaurs or gigantic reptiles. For Digipeter, the Cretaceous is a terrifying time to be alive. Or dead. Whether it's being hunted by Tyrannosaurus Rex or velociraptors or pterosaurs or just about any other predator that moved on the land or the sea, life for a mammal in the Cretaceous is the life of a snack. Sure, there's plenty of food around, but getting it is so risky. Imagine trying to snag some eggs from these guys. Now, unlike other extinction events, there isn't much lead up to the Cretaceous extinction. If you remember, some extinction events spanned millions of years, while volcanoes and climate change took hold, but not the Cretaceous extinction. It was as short as it was brutal. Cue poor, unwitting Digipeter, blissfully unaware, enjoying a brief dino-free moment near the Gulf of Mexico, just sitting on the beach, watching the waves, until the catastrophic moment the Chicxulub asteroid, a chunk of rock nearly 10 kilometers wide, strikes Earth at over 20 kilometers per second. The impact vaporizes its immediate vicinity and incinerates everything within 1,500 kilometers, causing tsunamis across the planet. Hurricane-level winds blast forests flat, and the impact crater jets trillions of tons of magma into the atmosphere, setting most of the forests worldwide on fire. The fallout is incredible, rubble and rocks strewn everywhere. So, how would you die? Well, if you're on one side of the world, it's incineration, shockwave, lava, or hurricane-force winds. If you're on the other side of the world, away from the shoreline, maybe you survive the initial impact. But the nuclear winter that transpires afterward? You wander a world where forests have burned to cinders, the sky is dark, and the ocean has, again, acidified. After you've been eating a steady diet of charred wood and fried T-Rex corpses, the food disappears. Then, eventually, so do you. But this extinction horror show leads to something important. The rise of mammals, and eventually you, and Peter, and DigiPeter. Without these mass extinctions, evolution would have taken a different path, and we wouldn't be sitting here today. Just in time for the next mass extinction. What'll it be? Well, hopefully, no big asteroids are coming our way anytime soon. Imagine if you could take in all of human history in the blink of an eye. Well, from the first steps out of the slime to the first steps on the moon. That's exactly where we are in cosmic terms, but in that short amount of time, we've done quite a bit. What would you see if you traveled 1 billion years into the past? Did Earth ever look like a giant slush ball? How far back would you have to go to see the first humans? And are we already going extinct? This is What If, and here's what would happen if you went 1 billion years into the past. In a sense, we're all time travelers. We travel into the future at the rate of 1 second per second. But if you want to go backward in time, you'll need to go faster than the speed of light. That's according to Einstein. Or maybe your time machine would jump through wormholes, a hypothetical tunnel that connects two different points in space-time. However you decide to travel through the jumbled mess of time, you'll see the effects and then the causes of the most powerful forces that shaped our world. You might leave wondering, how many times did the Earth freeze? As you watch history unfold or refold or whatever, you might be surprised at the toll humanity has taken on this planet in such a short amount of time. If you start in 2021 and move backward, you would watch the 6th mass extinction event happening right now. Known as the Holocene extinction, we are currently living through one of the most destructive periods of our time, caused by human activity. As humans destroy coral reefs and rainforests, the numerous wildlife and plants that depend on these ecosystems die with them. According to the International Union for the Conservation of Nature, 67% of endangered species could be extinct in 100 years. And since most of these extinctions are undocumented, we won't even know about what we've lost until it's gone. Maybe not even then. Visit the 18th and 19th centuries and you could watch the pollution created by the Industrial Revolution reversed back into the smokestacks. Cities would shrink down and return to their roots as rural farmlands. While this would let you see the explosion of the human race in terms of population and pollution, if you want to retrace our first steps, you'll need to go back farther. Tour the planet 200,000 years ago, and you would witness the arrival of our species, the Homo sapiens. Jump back 7 million years to northern Chad, and the oldest known species of humans could stroll right by you. Known as the Sahelanthropus chidensis, this mysterious link in our chain looked ape-like, but was the first to walk upright. He seems friendly enough. But Travel to 60 million years ago, and you'll see the first primates emerge from the humid rainforests of Asia. Okay, step back to 65 million years ago, and you'd find yourself under the giant asteroid that created a global extinction event. The impact caused a tsunami and filled the air with dust and debris. The crash also set off massive volcanic eruptions across the world. With the sun blacked out and the land flooding, the last of the dinosaurs died out. But without this event, mammals like us may never have taken over the planet. Go back 130 million years and you'll see the first flowers bloom. As you travel 200 million years back in time, you'll witness the breakup of Pangaea, the mass of land that will become the continents. As the land breaks apart, the lava eruptions will be so massive they kill almost 80% of the species on Earth. Okay, keep going back another 20 million years and watch the first early mammals, small and nocturnal, crawl around in the dark. And if you go back to 230 million years ago, you could watch the early dinosaurs walk for the first time on two legs. Before that can happen, though, the Earth has to go through what would be known as the Great Dying, also called the Permian extinction. 95% of all species on Earth died. But you could also watch the Earth's land masses come together to form Pangaea. Now you could take a walk from Argentina to China, but things get interesting around 375 million years ago. You would watch marine animals walking onto land for the first time. Maybe you would see a tiktaalik, which looks like a salamander mixed with a fish. This strange creature would later evolve into mammals and amphibians. But just like every species you saw before, this growth doesn't happen without a cost. And now, we're at the first extinction event. The Ordovician extinction occurs when ice sheets spread from the polar caps into the oceans. Almost 70% of all sea life died off during this planet-wide freeze over 460 million years ago. Okay, keep going back, and you could see how life started underwater. Called the Cambrian explosion, the lineage of most of the species on our planet today can be traced back to this milestone. But scientists are still unsure how this unique event happened. Between 635 and 850 million years ago, the Earth froze over twice. Once for almost 60 million years, and the next time for 15 million years. One theory suggests that the Earth was only covered in a thin film of ice, allowing the sun's rays to seep through and plant the seeds of life below. But go back 1 billion years in history, and you'll be surprised to find, well, not a lot. During this time, red algae are forming spores to reproduce. Cells are coming together to form larger organisms. Life on Earth is microscopic and not very threatening. But nothing has been more vicious to our planet in such a short amount of time as humans. But maybe humans will set things right eventually. There could be a change in our planet, or our hearts, that might set our future on a different path. Or maybe, like the dinosaurs and Neanderthals, we would just be replaced by something else. So let's take our time machine and find out. What if you traveled 1 billion years into the future? Well, that's a story for another What If.
This is Earth, 1,000 years in the future. Humans are long gone. What happened here? And what remains from our time on this planet? Well, today we're answering, if all humans vanished, how long would it be until Earth erased every trace of us? It's day one after every single human on Earth has disappeared. The streets are empty, the cars have stopped, bikes lay abandoned, the music gone silent. Squirrels and dogs and cats run through the city squares, along with the odd police horse. A bold coyote makes its way downtown. On the surface, the cities still look normal enough, minus the traffic and the crowds. Times Square and Shibuya Crossing stand barren, but the lights are still on. Traffic lights beckoning pedestrians to walk. The majority of hydroelectric and nuclear power plants are still operating, though no one is at the wheel overseeing them. Within a week, most will trip a routine breaker that a human supervisor would normally reset, and then the sprawling plants will shut down. Generators kick on in hospitals, their diesel motors keeping the city looking like it normally does, but they'll burn through their backup fuel within 48 hours. Generators running on natural gas will keep running longer. Cities start to go dark. They're still warm because most heating systems are built to run autonomously, but within a few weeks, natural gas compressors and distribution stations stop working properly due to pressure drops or power outages. In the colder parts of the world, the heat starts to turn off. In the warmer parts of the world, the food is rotting. Post-humanity smells. Within a month of humans disappearing, our usual comforts of modern life, electricity, heat, and running water, have mostly stopped working. Humans have built incredible automated systems to give ourselves power, control over the temperature of our homes, and nice warm baths. But guess what? Humans actually still do the stuff, or did the stuff, to keep all those systems running. Cities are blacked out. Wherever it's winter, towns freeze solid. Pipes burst, flooding houses and residential buildings. Fires and explosions are common. Behind the locked doors, it's basically cockroaches. Pets, farm animals, and zoo animals either die from starvation or escape their pens and homes and flood into the wild. Outside, it's pure chaos. Things have gone post-apocalyptic in real short order. Like in Chernobyl, packs of feral dogs stalk the streets at night. There is an exception, though. For cities that built their power grids around renewables, well, these solar panels keep turning photons into electrons. Wind turbines and hydro keep churning. In Reykjavik, the geothermal is still working. But all complex power systems have fail-safes and breakers that need monitoring and supervision, and without human direction, the major grids shut down, one by one. Within a year, all urban centers are dark and cold and silent. You remember books, right? Well, now, whether you had a library card or not, you'd have access to all kinds of critical information, if you could figure out the Dewey Decimal System. Outside of your home or apartment, the rest of the human world would start to slowly decay. The weeds and the riotous power of nature push their way into the human domain. Remember the pandemic? Yeah, those nature is healing videos. Well, most were fake, but now nature is starting to heal aggressively and overtaking the old human world. How long until it erases everything we've built? Well, we'll get to that, but you've probably been wondering, how did we disappear anyway? Now, the way humanity ends will have a lot to say about what actually remains for nature to heal. I've spent a decade YouTubing all the ways the universe could kill us, and there's just so many ways. On one end of the how does humanity die spectrum, it's possible that something out there in space could kill us. For instance, we've been keeping a close eye on the massive temperamental white dwarf star in the binary T Pyxidus system, about 3,000 light years away from us. Scientists estimate that it will go supernova in about 10 million years, which could completely destroy our ozone layer. So, what if we've missed a bigger, closer star that goes supernova without warning? It would hit us with a gamma ray burst so strong that it not only destroys all life on Earth, but also shreds our atmosphere and takes the entire crust off the planet. If we get hit by particles traveling 99% the speed of light, Earth gets sanitized. Or what if we don't spot an incoming asteroid, an interstellar runaway like 3I Atlas rocketing into our system at high velocity? That guy was doing nearly 7 kilometers per second, and if it hit, it was gonna do way